Good morning, all. Sorry to miss you the last few days. As you can probably tell from my voice, not feeling great. Both of my boys are homesick from school as well, so such is life. I want to go ahead and make this little video here. I don't want to keep falling behind with what we've been doing. So I've made this. You can kind of watch this on your own. Sorry to make you have to listen to this raspy voice, but I'll try to make it quick. You'll see at the top here, it's talking about midpoints and then the midpoints theorem. So obviously that's what we're going to be dealing with. What I want you to do first, it says label the coordinates of A, B, and C. So by that I mean go to point A. If we ask what point that is, this has an x coordinate of 2, a y coordinate of 10. If we go to B, that is 1, 2, 3, 4, 5, 6, 7, 8 for our x coordinate, and then we went up 2, so that's 8 comma 2. And then point C is 2, 2. That's what I mean by labeling those. All right, so then I want you to find the midpoint. So we understand midpoint basically just means the point in between, directly in the middle of the segment drawn between A and C. So it's this guy right here. And then I want you to label it point M and then write those coordinates. All right. So if we kind of look here, notice how if I go from A to C, I go 1, 2, 3, 4, 5, 6, 7, 8. So if I go a total of 8, then if I want to be directly in the middle, I would only want to go down 4. 1, 2, 3, 4. All right, that is what you're going to label point M. So we'll call that point M. And then you're going to tell me what those coordinates are. So those coordinates are 2. And then we go up 1, 2, 3, 4, 5, 6. That's that midpoint. Okay. Letter B, find the midpoint of segment C to B. So now if I go to segment B to C, that's going to be right here. We're going to go over 1, 2, 3, 4, 5, 6. So if I want to be directly in the middle, I would just go over 1, 2, 3. This point right here, we're going to call point N. That is the midpoint of the segment drawn between B and C, that blue segment. If we look at those, you're going to go ahead and label that. 1, 2, 3, 4, 5 is the x coordinate. And then we would go up to 2. That has the coordinate of 5, comma 2. All right. And then last but not least, the one that's a little trickier. The reason the yellow line and this blue line segment are nice is because it's a horizontal line and a vertical line. So we basically just cut in half the number of steps that we would take to do the entire segment. That gets us to the middle. If we want the midpoint of AB, it's a little sneakier because we're now looking for, let's do this over here, a slanted line. All right, so what we're going to do this one is rely on our slope a little bit, at least initially. You're going to go, if I went from this point, the next good point, actually, let's just do the whole thing. Let's just go from A to B. So if I wanted the slope of segment AB, I would go down 1, 2, 3, 4, 5, 6, 7, 8. So down 8. And then I would go right 1, 2, 3, 4, 5, 6. That's what I would do for the whole purple line segment. Well, if I ultimately want the middle, then that's half, right? It's cutting that thing in half, just like we did with the yellow segment, just like we did with this blue segment. So what I'm going to do is I'm going to take this and I'm just going to divide each of these by a 2, kind of like the dilations that we did last week, where if I just go down 4 and then right 3, divide each of those. So this negative 8 divided 4 gives me that, negative 8 divided by 2 gives that negative 4. The 6 divided by the 2 will give me that negative 3. If I just do that, 1, 2, 3, 4, 1, 2, 3, that point right there is the midpoint of segment A to B, and then we're going to label those coordinates. All right, we call that P, and that has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So those have coordinates of 5, comma 6. All right, so that's what we're talking about with the midpoint, is the point directly in the middle of a line segment. Okay. All right, 2. After labeling the coordinates of C, D, X, and Y, can you label the coordinates of the midpoint of each segment? So let's do C and D first. So C is 1, 2, 3, 4, 5, 6, 7, 8. So it has an X coordinate of negative 8. And then 1, 2, 3, 4, 5, 6, 7, 8, and positive 8. If we go to D, 2, 3, and then up 1, those are the coordinates of segment CD. All right. Then we want to go ahead and label that midpoint. So again, we could try to do the whole 1, 2. Let's do our slope. explain what we're looking for here. We could try that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So notice how this doesn't work out quite as well because we get these decimals or a fraction. We don't get these nice numerical values that we can just easily cut in half. So we could, again, kind of estimate this. We could cut 7 in half, and that would be a negative 3.5. We could cut 11 in half and get 5.5. And we could do that. So we go down 1, 2, 3. Here would be the halfway point, and then go right 1, 2, 3, 4, 5.5. But notice how it's not an easily identifiable point there. Okay, we're guessing a little bit in terms of where that would actually be, or we're going to have to do a little more math to figure that out. So ideally, we don't necessarily want to have to do that. Okay. So what I want you to really now do is let's go up here so we can kind of understand what our shortcut is going to be. All right. Notice what this point here was. I'm going to do point M. So we called this point, this was what, 2, and then comma 1, 2, 3, 4, 5, 6. All right. So here's how we can really do this to find the middle. Again, just understanding that middle. And this is going to be kind of what this midpoint formula is. So what we really would just do, take those x coordinates, the 2 and the 2, add those together. And again, think about middle, okay? And divide those by 2. All right, when I do that, don't we just get 4 over 2, which is a 2? Notice how that just so happened to be the x-coordinate of our midpoint. Now do the same thing. So I'm going to write this as a point. So here's my comma. I'm going to do the same thing with my y's right here. So A and C had a y-coordinate of 10 and a y-coordinate of 2. So again, I'm going to add those up. And again, if we want the middle, we really want the average of those two, and we just want to cut those in half. So if I did 2 plus a 10, that's 12. 12 divided by 2 is the 6 that we ended up getting for that midpoint. Okay. Let's do one more here. Let's do point P. So point P was drawn between A and B. So if I wanted the midpoint, all I really need to do is take these two x's, the 2 and the 8, and I want to average them together. I want the middle of them. So I basically just want 2 plus 8, divide that by 2, comma, and then I'm going to do the same thing with my y-coordinates. So 10 and 2. We want to figure out what's in the middle of those. So we'll add those up. 10 plus 2 divided by 2. And then look at what happens. This is 10 divided by 2. 10 divided by 2 is the 5 that we said was our midpoint. So this is our midpoint of this one. So that gives us the 5. And then the 10 plus the 2 divided by 2 is a 12 divided by 2, which gives us this 6. Okay? So that's the formula we really want to use for this one to make this as easy as possible. So our midpoint, I'm going to write this as one big point. Take the two x values that we want the middle of. We want to be in the middle of these two. So I'm going to take the negative 8, I'm going to add the 3, and I'm going to cut that in half. I'm finding the average of those. I'm going to do the same thing with my y's. I'm going to do the 8 and the 1. I'm going to add those together, and I want to find what's in the middle of those. So that would just mean us dividing it by a 2. So if I now simplify this, notice how this is a negative 5 over 2. This is a 9 over a 2. That is my midpoint. Think about what these are as decimals, just so we can kind of show this. This would be a negative 2.5. 9 divided by 2 is 4.5. If I come over here and go to the negative 2.5, so here's negative 1, negative 2, negative 2.5, and then I go up 4.5, 1, 2, 3, 4.5. Notice how I land directly on that line, and I now know that that's right in the middle of those 2 points. Okay? So, long story short, what you really want to just get memorized is what we call the midpoint formula. Okay, so the midpoint formula is us adding our x's together. So this is a set of parentheses. So take your first x, take your second x, you're going to add them up and then cut it in half. That should give us the middle. Do the same thing with your y coordinates. The y coordinate of point number 1, the y coordinate of point number 2, Cut that in half. That should give us directly in the middle of those. And then that's our new point. This comma will separate them. This is your new x-coordinate. That is your new y-coordinate. Okay? All right, so let's do a few of these. I think you'll find this largely pretty simple. So if I want the midpoint, what we just said our midpoint formula is. So it's a point, so that's why I'm going to write it as parentheses separated by a comma. What we want to do, what our formula is, I'm going to take x sub 1 plus x sub 2. So I'm going to add the x's up, cut it in half. That's the average of them. If I find the average of the y's, means I'm going to add up the y's, cut it in half. So what these variables simply mean is this is the x coordinate. X coordinate of point number 1, so that's a -7. This is the x coordinate of point number 2, that's the 5. We're adding those and then figuring out what is in the middle by dividing by 2. This wants the y coordinate of the first point, that's the 4. This means the y coordinate in the second point, that's the 8. Cut it in half. So add these together. This should give me a -1. This is 12 over 2, which is 6. That's the point in the middle of those two. Okay? All right. Okay, so there's our formula. A minute here. All right, so that's our midpoint formula. Again, we're just finding the average of the x values. That's in the middle. The average of the two y values should get us in the middle. So for this one, pen is not wanting to work here. The x coordinate of the first one is a 6. Plus the x coordinate on my second point is the -2. We divide that by 2. Then I want the y coordinates added up. So I'm going to take the -1, the -13, add those up. Divide those by 2. Whatever that gives us is our answer. So this should be 4 over 2. So that's a 2. This is a -14 over 2, which is a -7. That's our midpoint. All right, and then C, midpoint. All right, typically at this point, most people have a pretty easy time with this. You're just adding the x's, cutting it in half, adding the y's, cutting them in half. So for this one, x is 6, x is 7, so we're going to add those together. Y is a -3, y is a positive 23. We're going to add those together. And then if we want the middle, we're just going to divide by 2. So this should be 13 halves. This should be 20 over 2, which is a 10. That's the point in the middle between A and B. All right. All right. Number 3 says connect the midpoint of segment PR, which we'll call M, and then to the midpoint of PQ. We'll label that one and N. All right, so PR 1, 2, 3, 4, 5, 6. We can do this by counting. This would be 6. 1, 2, 3, 4, 5, 6. So the middle is 3. All right, so if we label those with an x and a y coordinate now, that is 1, 2, 3, 4. 1, 2, 3, 4. My pen is not working. There we go. So that's the point 4, 4. All right. Then we want the midpoint of this one. So to go from P to Q, I'm going to go down 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that slope was down 6, left 14. So if we want the middle, we're just going to cut each of those in half. We'll go down 3, left 7. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. That's our other midpoint. I then want you to connect the midpoint of PR to the midpoint of PQ. So go ahead and draw that in. And then it says, notice anything about the resulting segments, angles, or triangles. What we want to really kind of look at, what we're going to kind of talk about here in terms of the midpoint theorem, is that if I figure out how long this new segment is, this is 1, 2, 3, 4, 5, 6, 7 lengths. If I go to the line that it's parallel to, so notice how this is parallel, so that's one thing we kind of want to understand. Watch how long this one will be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So notice how that's exactly half. So basically what this is showing is if we draw a line segment that is parallel to the third side and it just so happens to go to the midpoint of the two sides that it's splitting, then the bases will also be half. All right, or this base will be half of that big triangle. All right, also twice as big. All right, so then that gives us this little theorem real quick. We get the midpoint theorems for triangles if the midpoint of one side of a triangle is connected to the midpoint of another side of the triangle. So that's what we just did here. We took the midpoint of this side, connected it to the midpoint of that side. Then the resulting segment is parallel to the third side. All right, so we can mark that with these little arrows that I have drawn in. So those are now parallel. And then that resulting segment, so that segment is 1/2 the length of the segment it is parallel to. All right, so what that simply means, let's say this is my midpoint, this is my midpoint. If I connect those two midpoints, that ensures that these are parallel. And it ensures that if this is, let's say, 5, then this has to be a 10. Okay? So pretty quick little problem here. So when we look at this, if I tell you that M and N are midpoints, so midpoint, what that tells us is the X has to be a 7. Because if this is in the middle, that means this segment and this segment have to be congruent. So that tells us that this X must be a 7. And then this is parallel to this side, which means it is 1/2 the size of the side that it is parallel to. So that has to be 22. Okay. All right. If I want the perimeter of TRZ, that means I just want to add up all of these segment lengths. So notice how we have these tick marks here. So if I know this was 3, then that means this side is 3. Notice how we have double tick marks here, double tick marks here. So if that's a 4, it tells me that is 4. So all we then need is the length of this right here. All right, because then we can add up. This is 6. This is going to be an 8. We want to add those up. All right, so if we'll notice, this is the midpoint because we have two congruent segments around it. This is also the midpoint of this side because these two segments are congruent. So this is the middle. This is the middle. That tells us that this is parallel to the third side. And this guy is twice as big as this guy. So now just be careful here. What that would then mean is that if this was 5, don't write this down, these guys, that would be a 10. So wouldn't we have to double 5 in order to get 10? All right, so in order to do this, kind of set up our equation right here. What we would want to take is I would need 2 of these. 2 of those x minus a 1 would be equivalent to that 3x minus an 11. Okay, because again, this guy is twice as big. So again, if this was 5, this was 10, I would need to double that to make it equal that other side. So that's what I just did. All right, and then you just solve this. So we'll distribute 2x minus a 2 equals 3x minus an 11. I'll subtract this 2x over. So I get negative 2 equals 1x minus an 11. Lastly, add that over, the negative 11, add over, so plus 11, we should get x to be a 9. Now, make sure we're answering the question. The question is we want to find this perimeter, so what I now need to do is take 9, let's throw it in here. 3 times 9 is 27. minus an 11. So that tells us that that length is 16. So the perimeter is these two guys here, which is 6. These two guys here, which is 8. And then we just found this full length here is 16. Add those all up. Perimeter is a 30. All right. All right, that is it. Again, sorry to bore you with this video. Hopefully I'll see you tomorrow. We'll see you guys.